Okay, today we talk about isosceles triangles and equilateral triangles, and our goal for today is to use the properties of isosceles and equilateral triangles. So we talk about the legs of an isosceles triangle. So leg is the vocab term. The leg of the isosceles triangle is the congruent sides of the isosceles triangle. So if you remember, isosceles means that I will have a triangle with two sides congruent. These two sides are called the legs. Okay? The base of an isosceles triangle, the side of an isosceles triangle that is not a leg. Okay, so this piece is the base. One thing that we should make note of is the base does not always have to be on the bottom. Remember, I can sketch an isosceles triangle that is this direction, and now the base is on the side. These two sides that are congruent are still called the legs. The base angles of an isosceles triangle. These are going to be two angles that are at the base of the isosceles triangle. Okay, so if I were to name this triangle ABC, the base angles have to be touching the base of that isosceles triangle, so B and C. If I name this triangle over here DOG, the base angles, once again, are touching the base, so that would be like angle D and angle G. Now, this first theorem is off of the base angle. So the base angle theorem, it says if two sides of a triangle are congruent, hence it being isosceles, then the angles opposite of those are congruent, okay? So if I go across the triangle from that side, I'm at angle C. This angle has to be congruent to the angle that's across from this congruent side, which is angle B. So if AB is congruent to AC, then angle B will be congruent to angle C because they are opposite of those sides, okay? The example problems that work with that, if I look at this congruent side, goes to the 52, that means across from this side over here should also be 52, which is the measure of angle L. Okay, next one says find the measure of angle F. Now, when I go across from these two congruent sides, there's nothing there. I don't know what those angles measure. But what we talked about previously is the sum of any triangle is 180 degrees. If I subtract the known angle, what I'm left with is 100. Now, I can't fill in 100 for both of those, otherwise I would be over 180 degrees. So what I'm going to do is take my 100 and split it in half because these two angles have to be congruent. So I'm going to end up with 50 degrees. I can say the measure of angle F is 50 degrees. Okay? The next theorem says the converse of the base angles theorem. And if you remember, converse just means that I take my information and I switch it around. So last time they talked about two sides being congruent. This time they start with two angles being congruent. And what they're going to tell us is if I go across from this angle, I'm at this side AC. AC will have to be congruent to if I go across from angle C, I'm at AB. So these two sides are congruent. Okay? So working with that idea there, if I go across from angle T, I'm at 12. Across from angle P, I'm at that x plus 3. They want me to find the value of x, and I know these two sides will have to be congruent. So I'm going to say x plus 3 is equal to 12. And when I subtract 3 from both sides, I'm going to be left with x equal to 9. And that's my answer. Okay? The next one says to find the value of x again. Okay? So I go across from this angle, and I'm at x. And across from this angle, I'm at 27. Those two sides have to be congruent. So x is just equal to 27, and that's my final answer. Okay? On the next one, it says find the value of y. Well, if I use that base angle theorem, or what I'm going to do is go across from this side, these are congruent, so I just say y is equal to 50. Okay? On the next one, they give me all three sides. I have to figure out, well, which sides are the legs? If I go across from this angle, I'm at 9. Across from this angle, I'm at the y. So y is going to equal 9. Same idea here. They give me all three sides. I can say that this angle down here is the base. And what that tells me is that these two sides have to be the legs. So y plus 4 is equal to 16. If I subtract the 4 from both sides, I get y is equal to 12. Now on to the next page. Now we're going to talk about equilateral and equiangular triangles. So if we get started, the equilateral theorem says if a triangle is equilateral, then it is equiangular. So what it's saying is if all three sides are congruent, that means all three angles have to be congruent. Okay, it works the other direction as well. If I see a triangle has 3 congruent angles, I can assume that it's going to be equilateral. Okay, so if we use those ideas here, it says find the length of each side of the equiangular triangle. Now, this is telling me the angles are congruent, but what we learned here is if it's equiangular, then it's also equilateral. So I can mark these 3 sides congruent. All I'm going to do here is pick 2 sides and set them equal to each other. Okay, if I subtract the 2x to get the x's to one side, I have x is equal to 10. Now from there, it asks me to find the length of each side. So what I'm going to do is take my 10 and substitute in here. So I take 3 times 10, this side length is 30. If I come down here, I get 2 times 10 plus 10, this gives me 20, plus 10, which is equal to 30. Well, they both came out to be the same measure because they should be congruent to each other. Okay, so same idea for number 9. If you want to, pause the video and see if you can try it. Okay, equiangular means that all 3 sides are going to be the same as well. So I'm going to say 6x plus 3 is equal to 7x minus 1. If I subtract the 6x, I end up with 3 is equal to 7x minus 6x gives me an x minus 1. To get x on a side by itself, I'm going to add 1 to each side, and I find that x is equal to 4. Now, it does ask me to find the length of each side, so I need to go back and substitute this value in. I take 7 times 4, and I subtract 1. I get 28 minus 1. The value of that side is 27. Okay, over here I take 6 times 4, which was my x value. I add 3. 6 times 4 gives me 24, plus 3 is 27. They came out the same. They should be the same. Okay, now we just have some mixed practice at the bottom. Okay, so I would say what type of triangle is it? In number 10, it's isosceles. If 2 sides are the same, that means 2 angles are the same. If I go across from those sides, I'm at this angle here. Across from this side, I'm at this angle here. So x will have to equal 70. Those base angles are congruent. On number 11, which 2 angles are congruent? Well, angle A would be congruent to angle C, so I could fill in 45 degrees here. Previously, we talked about if I have a triangle, it has to measure 180 degrees. And what I would do is subtract the 2 angles that I know. So if I subtract a 45 and a 45, I'm left with 90 degrees. So x is equal to 90 degrees. Okay. On the next one, number 12, I would say, what type of triangle is this? And it should be isosceles, because if 2 angles are the same, that means 2 sides have to be the same. So these 2 sides are our congruent sides. So I'm going to say 6x minus 1 has to equal 23. To solve, I'm going to add 1 to both sides. I get 6x equal to 24. When I divide by 6, I'm going to find that my x value is 4. We're done with that problem. Okay, taking a look at number 13, once again I would say, well, what type of triangle is it? It's isosceles. So going across from these 2 sides are going to give me my 2 congruent angles. And what I'm going to do here is say 6x plus 4 would have to equal 58. So from there, if I subtract 4 from both sides, I'm left with 6x is equal to 54. And when I divide by 6, I'm going to find that my x value is 9. Okay, down at the bottom, we have an isosceles triangle here and an isosceles triangle down here. I don't have any measures in this triangle, so I'm going to start with this one here. If I go across from these 2 sides, I know that these 2 angles are the same, so they're both 65. If my triangle has to total to 180 and I subtract the 65 and the 65, I am left with 50 degrees. So I'm going to fill in 50 degrees right here. So how does that help me get into the next triangle? These 2 angles are across from each other. We call them vertical angles. What do we know about vertical angles? Well, they have to be congruent. So this angle is 50. If I use that isosceles triangle theorem that we talked about earlier, this is 50 down here as well. So now I'm going to take 180 and subtract the 2 angles that we know, and we're left with 80 degrees, which means x has to equal 80 degrees for this problem. Okay. On the next figure, there's different ways to solve here, but this is the one that I like to take. Once again, I have 2 isosceles triangles. This box right here means that those 2 angles have to total to 90 degrees. If I already know that this angle here is 28, I'm going to subtract the 28 from it. I'm left with 52 degrees. So I'm going to fill in the 52 degrees right here. And now, since I have this isosceles triangle and I say the 52 is across from that side, across from this side should be the other 52 degree angle, I know a triangle has to total to 180 degrees. If I subtract the 52 and the 52, I'm going to be left with 76 degrees. So x is equal to 76. And that's all.